So in the chapter 7 review, let's start with 7.1 about variation, direct or inverse or neither. So there's some formulas that could be helpful to you. If you have x times y equals k, that is considered an inverse variation. If you have y equals k times x, that is considered a direct variation. So we can see very clearly problem number 1 is going to be considered an inverse variation. X times y equals 5. Number 2, if it said y equals 2x, it would be direct. But this number here is going to throw that off, that number right there. That is a linear equation that goes through 3, not through 0. And these both, this one goes through 0. So that's one way to kind of check for that. So that's neither. Now, if you're given a chart, if the things multiply together to give you the same value, so if they multiply together, the x and y multiply together and give you the same value, then you would consider it an inverse variation. So that's the first thing I would check. What is 7 times 35? So 7 times 35 is 245. Let me write that number down. And then 11 times 55 is 605. So because their multiplication is not the same k, that constant every time, we definitely know it's not an inverse variation. So it's not inverse. So then you have to check, is it direct? Now, how do you know if it's direct? Well, you can also look to see if you divide, well, how can we, if we take the y and divide it by the x, so instead of multiplying the two together and getting a number, if we divide y by x, we should always get the same exact thing. So let's try that. So here, 35 divided by 7, so always y divided by x is 5. 55 divided by 11 is 5. 75 divided by 15 is 5. 100 divided by 20 is 5. So that tells me it is direct. Sorry about that. Okay. So let's try the same thing for number 4. The first thing we do is multiply each pair. Will they give us an inverse variation? Well, 5 times 6.4 is 32. 8 times 4 is 32. 10 times 3.2 is 32. And 20 times 1.6 is 32. So this is an inverse. So that is how you can tell from either the equation or from a chart. Now, we're going to take it one step further. It says use the given values to write an equation relating x equals y, then find the value of y when x is equal to negative 3. So if they are inverse, again, you need to know that x times y equals k. And our job for both of these is to find the actual k value as our first step. So we know that 1 times 5 for this first one here would equal k. So k is 5. So let's go ahead and let's put the values now, leave x and y open, but put a 5 there. So we know x times y is always 5 for that equation. So when x is negative 3, put a negative 3 here, and then solve. So y would have to be negative 5 over 3. Now I put the negative in the top, that's customary. You can put it out in front. You can put 5 over negative 3 and then simplify it there. But that's your answer. And then how could you check if it works? Well, if I take this number and multiply it by that, I better get positive 5. And I do, because 2 negatives make a positive. The 3's would cancel out. The multiplication of those two things give us 5. Now let's do the same thing now for number 6. We know x times y has to equal k. I think the easiest way to multiply those is to divide by 2 first, and then multiply by 5. 2 goes into 18 9 times. 5 times 9 is 45, so k is 45. So our equation would be x times y equals 45. Now they said, what is the y value when x is equal to negative 3? So just put a negative 3 right there. Looks like my pencil decided to be. There we go. And then we have to divide off the negative 3. And so 45 is actually divisible by 3 15 times, and then just throw that negative out. So that's a little bit about 7.1. Okay. So hopefully that helps you there. It looks like I'm skipping 7.2, so let me know if I need to come back to it. 7.4 is about multiplying and dividing rational expressions. So the first thing you want to do, if it is multiplication, we're going to multiply tops with tops and bottoms with bottoms, but you want to factor first. So the first one is pretty straightforward. We can just multiply the top stuff and the bottom stuff separately. So on top we would have 80x to the 5th over y, and then on the bottom we'd have 5x squared y cubed. Now we need to check the numerical component. Can that reduce? The x's or y's, can they reduce? And so I think the easiest way is to kind of take each piece separately. 80 divided by 5 is 16. You'll notice that we have 3 extra x's on the top, because if you think about it, there's 5 x's there. Almost ran out of room there. And 2 x's. 2 of them would cancel. See, we have 3 left on the top. So let's put those 3 as an x cubed next to the 16. Now let's look at the y's. You'll see that's really y over y cubed. So when one of them cancel, this time the extra y's are in the bottom. So I think that's the easiest way to write it, so that you don't have to worry about negative exponents. Many times teachers are not going to want to see the negative exponents. Now for problem 18, there is some factoring that has to occur before we do anything else. Our first fraction, let's just take, and it's very easily factorable, only one step. The top I'm going to write in parentheses to remind you that the x and minus 3 go together. The bottom piece is divisible by 2. Now make sure when you divide by 2 that if you check it, you should get 2x minus 8, so you have to divide both terms by 2. Now let's take a look at that one. This would be x plus 3 and x minus 3, the difference of squares. I'm first above this one. I'm going to take out a 6. Now 96 is divisible by 6, 16 times. So first let me just write it right here, just because I know it's going to take us 2 steps, so it'll just make sense. So 6 factors out, leaving us with x squared minus 16. So 6 times 16 is 96. That's where you got that part. Okay. Now from here, that piece we see right here is actually a difference of squares. So we can do similarly what we did with the x squared minus 9. We can break that up. So it's 6x plus 4, x minus 4. So if it is more than one term, you're probably going to use some type of factoring. You're going to get all pieces on top and all pieces on the bottom factor. You can really think about all the pieces on top end up really multiplying, all the pieces on the bottom end up multiplying. So you could even just put dots between them if you have the urge. But let's take a look. The rule is we can cancel out any complete factor on top that is a matching factor on the bottom. So let's go ahead and cancel some of those out. X minus 3 and x minus 3, perfect matches. X minus 4, perfect matches. There's nothing that has an x plus 4 but the top. Same thing on the bottom, only an x plus 3. But the numbers here, 6 is divisible by 2. You treat it like a normal division problem. 6 divided by 2 is 3. You can write it like this. We can divide that one by 2. We can divide that one by 2. It does kind of leave a 1 behind if necessary. If a 1's on top, you need it. If it's 1 on the bottom, not necessarily. So on top, we have left a 3 and an x plus 4. And on the bottom, we have an x plus 3. We cannot cancel those out. I saw a poster once that said every time you cancel out something like that, a kitten dies. So morbid, but don't do it. It's an algebra no-no. You can only cancel out a perfect factor with a perfect factor. You can't cancel out a term with a factor. They're not the same. This is x plus 3. What if x is 2? 2 plus 3 is 5. 3 doesn't go into 5, if that helps. But anyway, there's 18. So that is the first two there, the multiplication. Now let's talk about the division. Okay. Now, for the division problem, we have to factor, but we also need to flip only the fraction after the division symbol. And if it doesn't have a part to it, put it over 1 when we flip it. Okay. Now we need to factor and flip, and you can do it all at once. You can do it in stages, however you want to do it. Let's look at 19. Now, this first piece here is a really good one to use slide and divide on. The 16 would slide over. What are the factors of 16 that add up to 8? That would be 4 and 4. However you do your factorization, that top piece ends up being 4x minus 1 times 4x minus 1. And let's check for a minute. If you check 4x times 4x should be 16x squared. Negative 1 times negative 1 is 1. Remember, if the back is positive, look to the middle. That sign will repeat in both of them. And then our middle term was made because our inner and outers become negative 8. Negative 4 and negative 4 make negative 8x. Okay, so that's the factorization of that top. Now, this bottom piece, if we factor out an x, we do have x squared minus 7x plus 12, which is factorable, okay? So let's now factor that one more time. So we have to take out the x, and that stuff is factorable. The factors of 12, look to the center, we're going to put a negative in both, that add up to 7 are 4 and 3. So that'd be x minus 4 and x minus 3. Okay, now I'm going to write a multiplication dot, and I'm going to flip this, and I'm going to put this on top and this on the bottom. Now, 15x cubed it's a monomial factor. You can't really rewrite it. Just write it again. Okay. But let's talk about this piece. If I check both pieces are divisible by 5, both pieces contain an x. So you want, for that piece there, you want to take out a 5 and you want to take out an x. Now think about when you do that, you have to do the division twice. If I take out 5x from 20x squared, I need a 4 and an x to remain. And if I take out 5x from 5x and there's just a negative there, make sure you put the negative 1. Now you can check your work. Go ahead and check. If you were to distribute that in, you better get 20x squared minus 5x, or you didn't do it right. Okay. Now that we have factored and flipped, so for division, factor and flip, then we can look for any common factors. Well, there's an exact 4x minus 1 and a 4x minus 1. That's always great. That's a perfect match. You don't have to really debate. There is this x here. So we have 1x and 3x. So we're going to have an x squared on the top. What else we got going on here? Well, the only other thing I see that is any sort of match is the 15 and the 5. Well, 15 and 5 are both divisible by 5. So if I divide by 5, I get 3. No, my 3 doesn't want to make a 3. There we go. That's almost a 3. And then that's 3 and 1. Now, let's look at all of the pieces that are left on top. I'm left with a 3. I'm left with an x squared. I'm left with a 4x minus 1. On the bottom, I have removed the x and left an x squared on top. Oh, there's another x. Oh, I'm so sorry. I didn't see that x. So now we would factor, and then this x squared over x, that would go away, and that would become an x to the first. I didn't even see that. Sorry about that. So let's make that an x to the first. And you can always do your work once, and then if you miss something, reduce one more time. Always check. Did I miss something? Because you can see it's possible. And then the only thing left, because I canceled that one out, I canceled the 5 and the x out, I canceled that one out. So the only thing left is an x minus 4 and an x minus 3. And so that is your division of rational functions. Let's do 20. Okay. So our left top and bottom aren't going to flip. They're just going to factor. So that's going to be x minus 8 and x minus 5. The factors of 40 that add up to 13, 8 and 5. Now, the bottom one has a minus in the back. That tells us we have to subtract to get the middle two things. And so we need the factors of 15 that have a difference of 2. And that would be 5 and 3. We need the 5 to be the bigger one, so that's at negative, so that we get the negative in the middle. And we need our littler one to be positive. I'm going to put a multiplication dot. The 1's going to flip up to the top, and the factorization of this now is going to go in the bottom. So the factors of 24 that have a difference of 5 are 8 and 3 have a difference of 5. 8 times 3 is 24. So the 8 needs a negative, and the 3 needs a positive. We're going to cancel junk out. 8 and 8 gone. That's perfect match. X minus 5 gone. Perfect match. X plus 3 gone. Now, technically, when everything is gone, when you divide something by itself, you are left with a 1. We actually get 1 over 1, which is 1. So when everything cancels out, it's like you've divided 2 by 2, you got 1. You did 7 by 7, you got 1. 8 by 8, you got 1. And so your final answer is 1. So that is multiplication and division. Hopefully that made sense for you there. Okay, sum and difference. Now, the difference between adding fractions, any kind of fractions, and multiplying or dividing fractions is multiplication and division. You do tops to tops, bottoms, like we just did. For these ones, you must have a common denominator. Okay, so we're going to look and see what the factors are. We're going to try to get the factors to match. For 22, our least common denominator needs to include a number that will go into, or I'm sorry, that both 2 and 6 will go into. So just use 6. We have a lone little extra x just hang in there. And then we also have that x plus 3 quantity. So our least common denominator has to include those things. Now, let's compare what we want our common denominator to be. I'm going to write each one here as a little placeholder. Okay. So if we look at this denominator, it has the 6. It has the x plus 3. The only thing it does not have is an x. So you're going to multiply that 5 on top by an x. Now let's do the same thinking here. 2 goes into 6 3 times, so we would need a 3 to make it a 6. It already has the x. It does not have the x plus 3. So we're going to multiply the top of that original fraction by a 3 and an x plus 3. Now, multiplication can be done any order you want. So put the 3 here and put the x plus 3 out there. Just, it'll make it clear as we go. Okay, so let's continue this process by making every one of our numerators as clearly multiplied out and defined as we possibly can. Okay, so our denominator is going to be 6x, x plus 3. This denominator is going to be 6x, x plus 3. Okay, and so our first denominator is 5x. Good. Okay, so here we're going to leave the 3. We're going to multiply out x plus 3 and x plus 4. Now, that's a FOIL. X multiplies by x and 3. 4 multiplies by x and 3. Now, when you do all that FOILing, you should get x squared plus 7x, because 4 plus 3 is 7, plus 12. Okay, now I'm going to multiply that by 3, and I'm going to set that over here. Okay, just for room's sake and everything. Okay, so we would get 3x squared plus 21x plus 36. Now and only now, once everything is all ready to go, we are going to write it all over 6x and x plus 3, and we are going to combine or add the tops. Now, to add a polynomial with another polynomial, when we add those tops, we can only combine like terms. 5x plus 21x is 26x. So we would have 3x squared plus 26x plus 36. Now, I don't believe that's factorable. I wouldn't worry about it being factorable. That is the answer to your sum. So I would just leave it, okay, for now. Okay, if it's clearly visibly factorable, maybe we'll mess with it. Okay. Now for 23, we can't really see what factors are in those denominators until we get them in factored form. So this would be x plus 3 and x plus 1. 3 times 1 is 3. 3 plus 1 is 4. This is the difference of squares, x plus 3 and x minus 3. Now the left side has an x plus 1 that the right side doesn't. The right side has an x minus 3 that the left one doesn't. So that's the guide, okay? Oh, I'm so sorry. There we go. Wait, I'm so sorry. We zoomed out in a weird way. Okay, so what are we going to do? Okay, so we know that our new denominator has to include an x plus 3, an x plus 1, and an x minus 3. So we need that x plus 2 to multiply by the extra one that the left side doesn't have, x minus 3. Okay, now let's write this denominator. This denominator does not have an x plus 1. So that 5x that was up there, it has to multiply on top and bottom by an x plus 1. Okay, so whatever's missing from the one side, you multiply on the top and bottom by that same thing. Okay, so we have to, just like the last one, FOIL everything out. So we know the bottoms are going to be this 3 pieces, those 3 factors. So we can just write that again. We don't have to think about what those denominators are going to be. But we do have to FOIL out the tops. So x plus 3 times x minus 3, let's FOIL. We get x squared minus x minus 6. And then here we get minus 5x times x plus 1 would be, I'm going to leave that minus there, but I'm going to put a parenthesis here just so it helps you hopefully not forget that there is a negative there. Okay, so it would be 5x squared plus 5x. Okay, now our new denominator, write it again, because now we get to combine the tops. So I'm just going to make a list first. It's going to be x squared minus x minus 6. Distribute this negative, making it negative 5x squared minus 5x. Again, write your denominator, keep writing it again and again and again and again and again. And then combine like terms. Okay, so we're going to go from high to low. These two are like terms. That's negative 4x squared. These two are like terms. That's negative 6x. And then we have that minus 6. Just, it's kind of extra. Now, even if you take out a negative 2 from all those pieces, we could, this one could possibly be factorable if we take out a negative 2. we're left with x squared plus 3x plus 3. Oh, 2x squared plus 3x plus 3. No, that doesn't factor. So yeah, you could have probably stopped right there. But sometimes, there's some kind of factor hiding that you can cancel out, like reducing fractions. But so that's a lot of stuff. So that is your adding and subtracting fractions. Factor the denominators, what is there, what's one missing, multiply that on top and bottom. Keep writing that new denominator again and again and again. Combine your tops. Okay, let's see what else we got. Okay, equations. Now, for an equation like 27, we know that when we have denominators containing x's, that x is not allowed to equal 0. X plus 2 is not allowed to equal 0. Those denominators are not allowed to equal 0. So we will have possible extraneous answers of 0 and negative 2. Keep that in mind. Now, when it's something like 27, that is a perfect fraction equals a fraction, we can, for these ones, just cross multiply. Awesome. It's the most lovely type of fractional equation. So if we cross multiply, we get 5 in parentheses times x plus 2 equals 7 times x. We get 5x plus 10 equals 7x. Now from there, it's just an equation. Just do equation stuff to it. Don't overthink it. Subtract 5x from both sides. We get 10 equals 2x. So x is 5. Now that is not an extraneous answer. Compare with what messed that up. It is not. The answer is 5. Bam. Great. 28. Same thing. It is a fraction equals fraction. Best kind, because we can cross multiply. Now, what are the possibilities of our, because they're mentioning check your solution because those extraneous answers. Well, this is really x plus 2 times x minus 2. Now, that doesn't completely help me necessarily at the moment for this, but x plus 2 is not allowed to equal 0, and x minus 2 is not. So those are both solutions we have to throw out. So x is not allowed to equal negative 2, x is not allowed to equal positive 2. So keep that in mind as you go through this particular one. Okay, I'm going to cross multiply. It's great. So 8 times x minus 1 in parentheses will multiply by x plus 2. So cross those, and then we're going to cross that. So 4 times the quantity of x squared minus 4. Just put them in parentheses so you don't do weird algebra stuff. Now, you can multiply in any order you want. So if you want to multiply these and multiply by 8, that's what I would probably do. Here, you just have to distribute. Okay, so what do we got? Well, we got 8 times the quantity of x squared plus x minus 2 equals 4x squared minus 16. Just going to multiply. I'm going to multiply that 8 through. I get 8x squared plus 8x minus 16 equals 4x squared minus 16. And then that's an equation that it's most effectively solved by getting it equal to 0. So let's get this junk to the other side. Now, how do I do that? Well, I need to subtract 4x squared and add 16 to both sides. Now, that's really great because the 16s cancel, so that does make life a little easier on you. So we get 4x squared plus 8x equals 0. Now, that's a quadratic that's most effectively solved if it can be factored. And it can be very easily. They're both divisible by 4 and an x. So take out that 4x, and we are left with x plus 2. So from here, you're going to set each of those parentheses equal to 0. This one gives you 0. Remember, 0 divided by 4 is okay. You can't divide by 0, but you can divide by 4. And then this one is x equals negative 2. Now remember, we had some values that didn't work. If you were to plug them back in, because you can do it later, or you can do this right off the bat. I kind of just jump in and do that. This one we have to throw out because of the fact that negative 2 makes the original thing blow up and not work. But 0 is fine, and so that is the answer that we would want. Now, before I do 29, I'm going to do 30, because technically 30 is, if we put this over 1 and we put these in parentheses, it is a proportion. It is a fraction equals fraction, cross multiply. Okay, so when you cross multiply, you get 2 times 1 is 2, and then x plus 1 times x minus 1 is x squared minus 1, and then, well, it's not a great thing to do, but you can add 1 to both sides, get that x squared by itself. X is plus or minus the square root of 3. Now, what values didn't work? Well, our only denominator is x plus 1, and that is not allowed to equal 0 at -1. Now, square root of 3 is not -1. Both those work, so your answer would be positive square root of 3 or negative square root of 3. So that the proportion ones are nice, just cross multiply. But of course, they had to throw in one that was not a proportion. So I want you to put the, well, do we have, no, okay, let's do this instead. We do not, in this case, care about the factors of our numerators. We only care about the factoring of our denominators, and our denominators are x plus 4 and 2 times x plus 4, okay? So for an equation where you can't do a cross multiplication, what you're going to do, you're going to surround the entire thing by parentheses, and we're going to multiply by the common denominator. So the denominators I see contain 2's and x plus 4's. So I'm going to multiply through by 2 and x plus 4, keeping in mind that x plus 4 is not allowed to equal 0. So if I get an answer of -4, bam, throw that out. Okay, now watch for a second. When we take this and we multiply it here, the x plus 4's cancel. That's what we wanted to happen. But we still have a 2 and an x plus 7 and an extra little 2. So we really have 4 and an x plus 7. Now, the 2, then, well, it's really a -2 if you want to think of it like that. It has nothing to cancel, so it just multiplies by the whole thing. So that's -4. You might as well put the 2's together, times x plus 4. And then this one, if we multiply this one, the 2's cancel, the x plus 4's cancel, you're just left with 2x plus 20. Now, once we've done that, it's just a matter of my suggestion. Let's multiply everything we can. Let's try to solve it. Let's see what kind of equation it really is. So we get 4x plus 28 minus 4x minus 16 equals 2x plus 20. In an equation, it is most effective to simplify both sides as much as possible before you do anything else when it becomes just a standard equation like this. So what's great, on the left side, the 4x's cancel, they're opposites. 28 minus 16 is 12. And then we get 12 equals 2x plus 20. So it's just a nice equation, right? And so you subtract 20 from both sides. You get that 2x equals -8, so x is -4. Oh, look at what our bad value was, -4. We're going to cross it out. There is no solution to this one. Nothing makes it work. Okay, so that is the equation part. So the key here, cross multiply, unless it isn't a proportion, get common denominators and multiply through by that common denominator if it looks like 29. So that's those, and that is it. So good luck to you, and I'll talk to you soon.